Okay, guys, welcome back. Today, I want to talk about searching. One of the principal things that we do with data is search for data or classify data. Short. Tomorrow, I want to talk about shorting, searching. You have an array, and basically what you want to do is to know if one of the elements in the array is something that you need. The number 5, you want to know if the number 5 is in your array, assuming that the array is numbers. Or you have an object, and that object represents a student with a grade 100, and you want to know if you have a student in the array with a grade 100. Searching. Yep. The shortening is going to be part of the review. I'm going the question in the chat. Searching is going to help me to start with the review. And talking about shorting classification is also going to be a very good exercise for you thinking about the exam and the review. We're not going to view today any new topic. What we're going to do is to put together things that you already know with a common goal. Today, the common goal is searching, but all the elements that you need in terms of programming, in terms of Java language, are things that you already know, but putting things together. Searching. Obviously, if I want to do this, I need arrays. We're going to talk about arrays today. But also, searching, as you can imagine, is a loop. If I want to know if this array have a number 5, or if the array have a student with the grade 100, at this point, I am sure that you know that basically what we're going to do is a loop to check this element, this element, this element. And inside of the loop, we're going to have an if condition. And the if condition somehow is going to involve a particular element in the array. At this point, I hope that searching, you can translate that concept to a for that have inside an if that somehow is doing something here with square brackets, elements of the array. Those 3 elements are going to be involved with our concept of searching. And in that particular order, the if is going to be inside of the for, and inside of the if, we're going to be working with elements in the array. 3 elements together, conditions, initializations, variables that we need to use, maybe more variables that use the array, but that is going to be our searching. And tomorrow I am going to tell you exactly what is the meaning of sort. But for today, there are 2 ways in which we can do the searching. These 2 are the simplest one, the easiest ones. There are more. And you're going to review more in your data structure class, 200 level class next semester, if you're taking that one. For this class, and only for the purposes of reviewing the loops, the conditions, and the arrays, I want to share with you 2 algorithms, 2 ways to do searching, and for you to get familiar with the concepts. Linear searching. Linear searching, used like that, the key idea is you have your data, elements, and one by one, starting with the first one, the 0, you are going to check, this one is the one that I am searching for? If yes, done. If not, look the next one, or the next one, or the next one. In a line, linear searching. As a practice, this one, linear searching, having an array and check element by element, starting with the first one, and check if the one that you are searching for is in a particular position. I am pretty sure that with the knowledge that you have, you can implement that one. 5 minutes, 10 minutes. Don't worry, I am going to show you the source code. But right now, if you start thinking about how to implement that one, you have all the tools that you need to do this. In fact, this is very similar to something that you did in a lab. Remember that lab, that problem with, I want to know which is the smallest element in the array, or the biggest one, whatever version you solve. You were doing linear searching. Now, that one is very easy to program. It's going to be a for loop with an if. There is another option. Another option, because this one can be very, very slow, right? I mean, what happens if the thing that you are searching for is at the end or something like that? Can take a lot of time. The second option is binary search. Binary search, if I want to explain this to you, is the searching that you do when you use a dictionary. When you use a dictionary, you know that the information, the data, is in order. The A is here, right? Because you know that the information is in order. If you're going to search something in the dictionary, never you start reading the dictionary from the beginning to the end, right? What you do is maybe open randomly the book. So you are in some place there. And when you read, basically what you do is check if what you're searching for is after or before. If you're searching something with a C and you open the dictionary in the B section, well, you know that you need to go back a little bit. If you're searching for something with B, you need to go back a lot. But basically, you never go to the last element. Most important, you never start with the first one, because you do not need to review all the A letter if you know that you're searching something with D or B, whatever. This, what you do with the dictionary, binary searching. Why binary? Because always, 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 you consider the data in two parts. The information that I am searching for, a B, I check in some place, and is the ones that I need to continue searching or to continue reviewing, and the other half that I don't care because I am sure that my information is not there. Open the dictionary, and only one part, the first one or the second one, is the one that I need to continue searching, because the other part is not important. It's not the one that has the information that I want. Binary searching, linear searching. What we need to do today is to program both of them. Yes, linear searching works with any data. Binary searching, one thing that is mandatory, the only way that binary search works is if the data is in order. So alphabetical order with the letters or numerical order, whatever. The data should be sorted. The data should be in some kind of order. If not, you cannot use binary searching. So tomorrow, something that I want to share with you is how to do the sorting of an array if the array is not short. So what we can do is the sorting first and then binary search. Or we can apply linear searching. In your data structure class, you're going to talk about which one is more efficient, which one is better, when to use one or the other. As I mentioned before, our goal here with both the two algorithms for searching and the two that we are going to review for sorting is giving you the opportunity to play a little bit with loops and conditions using arrays. That is our goal, playing with those three tools. You are going to have the opportunity to continue playing with the sort and search in future classes. Good? So, programming. I explained you this, and I explained you this. And my goal is, with the information, you can start thinking about the algorithm. And then you can put the algorithm in terms of Java programming language. Let's start with the first one, linear searching, the easy one. By the way, I need to show you something regarding recursion, 3 slides that I didn't use yesterday, and I am going to use today, and they are connected with binary searching. So we're going to apply recursion to implement one version of binary searching. So linear searching first. For this one, as I mentioned before, and I want you to have this picture on mind, you have an array. And the only thing that you're going to do is access one by one all the elements in the array. What do you need to do that? Can you agree with me? Access one by one all the elements in the array. We're talking about a loop. We're talking about a variable that you need. I am clear why the variable should be equal 0 at the beginning, the first element. We need to stop the loop. At this point, you are familiar with this variable lower than. And what do you think I need to put here? Lower than. Option number 1, you can count how many boxes do I have in my array. Option number 2, you can use the generic solution. Thank you. Whatever is the name of my array, dot length, right? That variable that we reviewed when we was talking about arrays. Other than that, something is going to be inside. Something inside. Can you agree with me that basically I am searching for something? Let's think about numbers. And I have 2 things that I want to do. The first one, if I found the value that I am searching for, I want to stop the loop. I want the loop to end, right? Because the goal of the loop was for me to search for the element. If I found the element, I want to stop. And if I do not find the element, I want to continue searching. That description that I give you, can you imagine the Java version for that? Number 1, I am talking about doing a condition, right? Because it's continue searching or stop, depending of something that I need to compare. Agree. You remember that it's like, well, we have this option to break the loop. We have this instruction break, right? Could you agree that we need to put the break inside of some kind of condition? The condition is going to be something like the array in a particular position that could be X, the loop, equal to whatever I am searching for. As I mentioned before, this is linear searching. These are the elements that we're looking forward to use: the array, the loop, the condition. Now, this one is the source code that you need. It's a source code that maybe we're going to use a lot in a particular system. It's a source code that maybe you want to put in a particular method. Do you remember? In a particular paragraph in your program, in a particular space, you want a method, and that method is the one that is going to do the searching. What do you think about this method? One, the green lines at the top, comments, right? Putting elements together. Comments. I want a method. The method can receive information. The method can return information. Something that I want to do is to have a method that returns the index, the position in which the data was in the array. If the data was in the array. If the data is not in the array, if I am searching for something that do not exist, well, I want to return -1. Can you imagine why -1? Why not 0? Well, if I return 0, I am telling my user that the data is in the position 0, because 0 is a valid position in an array. If I return -1, just because -1 cannot exist, is not a valid position in the array, my user can understand that the data is not there. -1, the data is not in the array. 0 to whatever is the size of the array is going to be the position if I found something. Now, that is the returning. What about the parameters? Well, if I want to search data in an array, what about sending as a parameter to this particular method the array? Now, at this point, hopefully you remember that having that parameter receiving an array, well, it's not receiving the array, not all the elements. What it's going to receive is the address of the first element, the reference to the array, remember? With that, we can access the data in the array. We have the address of the first one, we have access to everything. The only thing is we need to be careful that if we change something in the array, we are changing the original, not a copy. But that is fine. The only thing that we're going to do is searching. So the only thing that we need to do is read the data. We are not going to change anything. So it could work. A method that receives as a parameter the array is going to return the position of something that I am searching for if that something is inside of the array. I need also that something. It's a method. I send the array and also send the information that I am looking for. In this case, a number. So here, this is my array. This is the number that I am searching for. And you, method, do the work, search for this element, the target, in the array, and just tell me, return to me the position, 0 to whatever, or -1 if you didn't found the information. It's like separation of concerns. I have the array, I am the one searching for the data, but I am creating another method, another paragraph in my document. I am giving that paragraph, that method, the information that that paragraph, that method needs as parameters. And the method is going to give to me an answer. Putting things together. At this point, you understand why this method is public, static, the int, and all the parameters, including the first one that have the brackets. Why I am making this method public? One reason, because I can put this method in one file in my program. And when I put the public, any other method in the same file, but also in other files in my program, are able to call this method, right? Public, give access to other classes, do this one. Moreover, I make this one static. If I told you that I put this method in a class algorithms, can you imagine what I need to do in order to call this method from the main in your programs? Hopefully you agree with me, algorithms dot linear search. And if you remember, that is very, very similar to what you do with math.pow, math.sqrt is one class with mathematical things that you need. Here, I could create one class with algorithms. Maybe I can put here the 2 algorithms for searching, and tomorrow I can add the 2 for sorting or more. By the way, you have a class algorithms in Java. All of this is part of the libraries that you can use, but for our purposes, what we want is you programming this. If this method is in the same class, remember, you only need to put the name of the class if you are calling the method from another class, from a different class. So if your main is in a class exam, and this guy is in the class algorithm, you have 2 classes, you need to put algorithms dot and the name of the method in order to call the method from the main. But if you put this method in the same class that you have the main, you do not need the name of the class. You only put linear search and that's it. You only need the name of the class or the name of an object when you're calling methods that are not in the same class. If they are in the same class, the only thing that you need is the name of the method, period. Good? Okay, so going back to my algorithm. I think the header makes sense, the comments make sense. Now I can talk about what we have inside. What we have inside. Green lines, comments. I can ignore those. We talk about a for loop. By the way, this is a method, and because it's a method and it's going to return an integer, something that I need to do is to return something. Return something. I am going to return the value of a variable, position. It can be any name. Position is the name that I choose. Well, if I am going to return the name a variable, I need to create a variable. By the way, I need to provide an initial value. And in this case, my initial value is going to be -1. So at this point, I have the variable, and I am going to return the variable. And at this point, I have solved one part of the problem. Return -1 if nothing was found. The only way to return something different is if I found what I am searching for. Okay, this is the variable with an initial value. This is the return for that value, and everything else, the searching. And as we described before, the for loop, variable, start with 0. Variable lower than the name of the array, numbers is the parameter, right? Dot length, you give me that solution before, and the increment for the variable. Inside of the for loop, a condition. The condition, the array in the position index. The first time is going to be 0, the second time 1, 2, 3, and so on. And the only thing that I am going to do is to check if that element in the array is equal, remember, equal, 2 equals, not 1, comparison, relational operator, with the value that I receive as a parameter. 2 options. The condition could be true or could be false. If the condition is false, I do not have an else. I am not going to do anything. What is going to happen? Go down and return to the loop. I didn't do anything. So the if is going to happen again with a different index. The loop is going to be there. However, if the condition is true, I am going to execute the source code that I have inside of the if. What I am doing there? Very easy. The current index of the loop, I am going to store that value in my variable position. It is clear that the only thing that I am doing is whatever is the index of this loop right now is the position of the data that I am searching for because this condition was true. Yes, if the condition is false here, remember, if this condition is false, it's going to go to the closing curly bracket, go to the closing curly bracket, the if finish, but then go down to the closing curly bracket of the for, and that closing curly bracket is going to make the for to go back. So if the condition is false, the loop continues. If the condition is true, I am going to do this, saving the data and executing this instruction break. You mentioned break before. If the condition is true, I am going to execute break. And you know what happens when you execute break. If you execute break, you go out of the loop because break literally breaks the loop. If you execute break, you are going to go out of the loop, out of this red curly brackets. And when you execute break, because you go out of the loop, in that point, you're going to find the return and the return position. And what is the value of position? The last index, the index in which you found the element. What happens if the condition is never true? What happens if you never execute the break? The for is going to finish in some point when this condition here is going to finish the loop. And if the condition of the if was never true, that means that the value of the variable position never changed. And if the value of the variable position never changed, then still have the initial one that I put here, -1, and this return is going to return -1. All the different possibilities are covered. If I have an array and that array have numbers, 10, 5, 1, 2, 3. What happens if I am searching for the number 4? How many times this loop is going to run? How many times I am going to do the comparison in the if? Question for your exam. Can you agree with me with 5? The loop is going to run with the value 0, 1, 2, 3, 4, 5 times. The if is going to be executed 5 times. How many times the break was executed? Never, because the condition was never true. What is the value that this method is going to return? -1. Why? Because -1 is the initial value, and because the condition was never true, the value for the variable position here never changed. 5 elements, 5 times run the loop, 5 times the condition was executed. The break never was executed because the conditions, all of them were false. And the return value is -1. Okay, what happens if I am searching for the 1 in the same array? How many times is going to work the loop now? 5? Multiple choice question in your exam. I am searching for the 1. I have this source code. How many times the 4 is going to run? Well, hopefully you agree with me. It's going to run, yeah, thank you, 3 times. Because it's going to run with the 0. It's going to run with the 1. And when it's running with the 2, this condition, numbers in the position 2, that one is 1, equal to target. Target is 1. 1 equal 1. True. If the condition in the if is true, position is going to be equal to index. So position is going to be equal to 2. And then you do the break. And the break stop the loop. So the loop run 3 times, period. And you go out. And when you go out, you return position. And position is 2. So you return 2, not the -1, the 2, because you execute these 2 lines here. That is the easy way to implement searching. And that is the source code. Not only the loop and the condition, but with a fancy method that return the position and receive as a parameter a reference to an array and an integer number to represent what you are searching for. Questions? Easy, right? For, if, and why not parameters with arrays. Okay. Now, advantage of this one, the information do not need to be in order. So the information could be like this, 10, 5, 1, 2, 3, you don't care. Disadvantages. This is not the best way to search. Why? Because if you're searching for the 3, it's going to be a very long search. It's going to take a lot of time, but it's easy to implement. Moving forward, another option, binary search. I already mentioned to you the goal. For this one, it's going to be faster than the previous one. However, the information needs to be in order. In order to do a binary search, you need to provide the information, like I mentioned before, a dictionary. So you already have the dictionary in alphabetical order, therefore that helps you to find something quickly than if you're searching something in an unordered book. Binary search. The goal for binary search, the key idea is this one. Why? Because as mentioned before, you have the data. If you're searching for something, the first thing that you're going to do is to compare the element in a middle point of your data, the middle point of your array. Why? Because the only thing that you want to know is if the thing that you're searching is here or there. The only thing that you want to know is, okay, I have all this information, I am searching for something, and I need to know if that something is in the first half or in the second half. Then you apply the same rule again, and you're like, okay, it's going to be here. You're going to go to the middle and check, okay, is here in the first half of that middle half that I already could, or is going to be in the other one. Obviously, in the other one, stopping here because we already eliminate this part. So this idea of could in two parts is the one that gives the name binary searching. Obviously, again, the information needs to be in order. The example of the dictionary. Well, looks simple, kind of. More complicated than the previous one because we're talking about the beginning, the end, this idea of a middle point, and this idea of working with half of the array. We need to review what to do. But so far it's like, cool work. The ideas, just to be sure that it's clear, because before I start programming, always, guys, understand the problem and how to solve the problem in paper. And then we can worry about writing this in Java. I'm winning the question in the chat. Yes, the for and the if 3 times. Because if you review the code, every time that the condition is true in the for loop, then you run the if condition. So both for and if 3 times in the previous example. Sorry, I just read the question. Good. So going back to binary. Binary, imagine that I have this array. And imagine that in this array, I am searching for the number 29. It's an integer array, and I am searching for the 29. I know that the 29 is there. Well, I know, but the computer needs to do the searching. For the binary search, what we do is the following. Starting with the first one, the full array, and the last one, first index and last index, we need to calculate the middle point of the array. So hopefully you agree with me that if I have this array of, how many elements do I have in the array? 10? 11, thank you. Remember, 0 to 10, the index. That means 11 elements. If I have 10 elements, the index goes 0 to 9. I know, it's the tricky part with the rest. Good. I need to find the middle point. The middle point is this 5. And I'm sure that you are thinking like, well, if you have 11 elements, the middle point is 5.5. Yes, but we're working with arrays and we cannot work with decimal numbers. In fact, the solution is going to be the following. You can take the 2 index, add the index, and divide by 2. So in this case, 10 plus 0 divided by 2. And remember that Java do the division by 2 with integers. So in Java, 10 plus 0 divided by 2, that is going to give me my middle point. And that is going to give me this 5. And therefore, the middle point is there. And what I am going to do is to compare the number there, 54, with the number that I am searching for. They are equal. If they are equal, I can stop. I found what I was searching for. They are not equal. Okay, they are not equal. The one that I am searching for is greater or lower than the one that is in the middle point. You can agree with me, 29 is lower. Well, because 29 is lower and the array is in order, that means that basically I can ignore all these elements in the array. The array is in order. The one that I am searching for is lower than the one that is in the middle. Therefore, I can ignore all the second part because the 29 is not going to be there. The array is in order. Moreover, I already compared the 29 with this 54 and they are not equal. So in an array with 11 elements, after use one comparison, I eliminate from the 5 to the 10. So if the 29 is in my array, it's going to be in some place 0 to 4. If the array is not in order, you cannot use binary search, period. It's not going to work. Well, you can run and your computer is going to do crazy things, but it's not going to work. It's mandatory in order to use binary search that the array is in order. It's a precondition here. If the array is not in order, the solution is use linear searching. That's it. So the power of binary searching, even though we need to put the data in order, is, check this, one condition, only one condition, one comparison, and we eliminate more than half of the array. And that is a lot of time. Again, the same thing that happened when you're searching for something in the dictionary. Now, what I need to do now? Next step is I need to repeat the same thing that I did before, but now only considering the data 0 to 4. 0 to 4, calculate the middle point. 0 to 4, the middle point is 4 plus 0 divided by 2, 2. This guy here is the middle point. Now that you have the middle point, do the same that you did before. You are searching for the 29. 29 equal to the element in the middle? No, they are not equal. Okay, is greater or lower? The 29. The 29 is greater. Is bigger than the 22. Okay, that means that all these elements here are not the ones that you're searching for. Neither is this one. Two comparisons, and you already eliminate these ones in the first comparison, and now in the second comparison, you are eliminating those ones. So after only 2 comparisons, only 2 times checking the condition, in an array of 11 elements, now you only need to check 2. Okay, What I do next? The same thing that you did before. Again, the same thing that I did before. What? Using only those two, found a middle point. Your first element is the 3. Your second element, or the last one, is the 4. 3 plus 4, 7, divided by 2, 3. This one is the middle point. You're searching for the 29. 29 is equal to the middle point. Yes, they are equal. After only 3 conditions, 3 comparisons, you found that 29 is in the array. Moreover, 29 is in the position 3. Only 3 times. Binary searching. Okay. Now, help me to organize my ideas. Important things here. Always, 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 we are talking about a starting point, an end point, and a middle point, right? The first time, the starting point was the first element in the array. The end point was the last element in the array. So 0 and 10, we were searching in the full array, and we calculate a middle point, and our middle point was 5. So first one, last one, and the middle point. The middle point was 5, and the element was 54. We compare the one that we are looking for, 29, with the 54, and basically the result was the one that I want is smaller, which basically means that I need to look in the first half. I need to continue searching, but now my searching is only limited to the first half. So for the second time, I am using as a first element the 0, but now I am not checking until the element 10, because I know that the element I am searching for is smaller than this one. So my stop point, my end point, should be the 4. So now the second time I am looking between the 0 and the 4, and what I do is to calculate the middle point, and that middle point is 2. And what I did is, again, compare the one that I'm looking for, 29, with the one in the middle, 22. And again, my question is it smaller or greater? In this case, it's like, oh, that 22 is smaller. Oh, because the 22 is smaller, now, instead of changing the endpoint, something that I did before, now what I am going to change is my start point. It's not going to be 0. It's not going to be 1. Moreover, it's not going to be the 2, because 29 is greater. So 29, I need to search for the 29 between the 3, and I did nothing with the 4. Between the 3 and the 4 should be my 29, and I calculate a middle point. And what happened is the middle point is the one that have the 29, so basically I stop there. And with 3 comparisons, I found the 29. Could you agree with me that probably those ones are variables that I need in my program? That could be a good idea to have those variables start, end, middle, or similar names, different names, but I am going to need those numbers And so far, if you think about the algorithm, we need a for loop. I think we're going to need a condition inside of the for loop, at least one. Moreover, inside of the condition, inside of the for loop, every single time that the loop runs, I think what we're going to do is somehow update start, end, and middle. Because it's what we did here on paper. Start, end, middle, and this comparison between the middle and the value that we're searching for. Something like that is going to be our program, right? Very good question. What happened here is like, oh yeah, you are searching for the 29 and you found the 29. But what happened here, if I am searching for the 36, iteration number one, the same. I compare with 54, 36, 36 is smaller, so I am going to continue searching here. Second comparison here, 36 compared with the 22, that is the middle. 36 is going to be greater, so I am going to continue searching there. So far, the same. Now, 36, the middle is 29. 36 is equal? No. Okay, I need to continue searching. 36 is small or greater than 29? It's greater. Okay, so that means now, the next time, it's not going to be this one. Now this 4, the next one, because it's greater, the 4 is going to be my new start. And the 4 is still my end. And the 4 is going to be my middle. One iteration, additional, right? And what is going to happen? Well, I am going to compare the middle with the 36, and I found it. So if I am searching for the 36, I need one more iteration, but at the end, following the same process, I am going to find the 36 also. Makes sense. Now, what happens if I am looking for 30? Well, if you're looking for 30, this is going to be the same. This is going to be the same. This is going to be the same, that's for the 36. And when you arrive here, is your start is 4, your end is 4, and your middle is 4, and you compare the middle, 36 with 30, and they are not the same. They are not the same, and the problem is I cannot change the start at the end to something that makes sense. When you have the start at the end, these two equal, and the value is not the one that you are searching for, you are sure that the value is not in the array. Because if the value, the 30, exists in the array, that is the position in which that value should be. So following the same process, in this case, in 4 iterations, I can find the 36, that is the most difficult, or I can be sure that some number like this one do not exist in the array. Again, because the array is in order. Good? Okay, the source code. We have the ideas. The only thing now is we need to put those ideas in a program. And you know what? This one, think about the solution with loops, and why not? Think about the solution of this with recursion. because this looked like something that is recursive. This looks like something that we are doing the same again and again and again and again with different values. But if you think about this, beginning, end, calculate the middle, compare the middle. If the middle is the same, done. If the middle is not what you're looking for, apply the same rules. Start, end, middle. Start, end, middle. That is recursive. Well, let's review first the source code with loops, the easy one. Solution. Again, green lines, comments, everything else, let's check. This is an algorithm. I am going to do a method for this. I am going to do a method and I am going to follow the same idea that I described before. I want a method, public and static. It's going to return an integer. It's going to be the position, right? And it's going to receive the array, data, and it's going to receive what I am searching for. Just like the linear one. The array, what I am looking for, and it's going to return an integer. An integer, the position. Or I am going to return -1 if I am not able to find the value. Okay, next. Obviously, I need this variable position because it's the one that I am going to return. And I put an initial value -1 because worst case scenario, if all the lines that I have between this and this do not do something else, I am going to end returning -1. Now, for the source code, for the algorithm, before I mentioned several times this idea of start, end, and the middle. Well, let's have variables for that. Start, why not? It's going to be 0 the first time, the first element. End is going to be the last index. So data length -1, right? So in my array with 11 elements, the end is the index 10, start, and end. And also I have my variable for the middle. I can calculate here the middle. I am going to wait and I am going to do that after in the following lines. But start, end, and middle. And I put initial values for start and end. That's it. Now, in this particular case, I need a loop. But this loop, I do not know how many times it's going to run. I mean, it's not like the linear searching in which I am using a loop 0 to the last element. In this case, if you notice, I am not doing something for all the elements. Usually, for this kind of problem, my recommendation could be for loop is not the best option. For these cases, usually you're going to do a while or a do while, whatever. My recommendation here, my idea here, but you can use something different, is we can try with a while. I have a while here, and well, just to practice a while with this crazy condition. I am going to do a loop, and there is 2 options to stop the loop. Option number 1, the loop is going to stop if found is true, or it's going to continue if found is false. Any way that you want to read this. That is one thing. Obviously, the first time this is false, this is going to be true. The condition is going to allow the loop to continue. The second thing, as you noticed before, is, well, I want this loop to continue only if the value for start and the value for end are start go first, that end. So in my previous example, start, end, start, end, start, end, start, end. But if you calculate again these things, like when you didn't found the 30, because the 30 was not here, you need to move in this direction, and then the end become 3, but your start is 4. You, instead of doing this, you stop here, because now it's this idea like the end move before the start. This is one way. The other way, as I mentioned before, is if start equal to end equal to middle, if the 3 numbers are equal, you stop. Different ways to put the same. You want to stop when you cannot continue moving the index. So for the exam, an operator, 2 conditions, while loops. Okay, in this case, start is 0, end is data length, whatever is the size of the array. So I am sure that 0 is going to be lower or equal than the size of the array. Even if the array is 1 element, 0 is going to be lower or equal than 1. So at least one time, this while is going to run. It's going to run. What is going to happen inside of the while? Well, do you remember what we did? Number 1, calculate the middle. So we start with 0 and 10 in the example before. We calculate the middle. Remember that I mentioned this, start plus end, 0 plus 10 divided by 2. And because we are doing the division with variables that are integers, the result is going to be integer, so we do not need to worry about the decimals. That one is going to give me the 5 that I had before. And then a condition. What was the condition? The array in the position middle, the array here, is equal to what you are searching for. If it's equal, found is true, and position is middle 5 in this case. Found is true, the position is 5, and that's it. Because this is inside of an if condition, so if you run these instructions, you are not going to do this, and you are not going to do this. You are going down, and what you are going to have is the return of the while, and you just change found to true. So this condition is not going to be true. The loop is going to finish, and you're going to return position, and in this case, position is 5. Well, that is the good case scenario in which you found middle equal to whatever you're searching for. What happens if this condition is not true? What we did before. I need to know they are not equal. So if they are not equal, I have another condition here. The other condition is, well, the one in the middle is greater than the one that I'm searching for. Like before, remember? We were searching for the 29, in the middle is 54. That is true. The one in the middle is greater than the one that I'm looking for. If that is true, the only thing that we did before is, you know what? Now your start is still 0. But let's change the end. The end is going to be equal to the middle minus 1. Remember? The middle was 5. Now our end is 4. Because the next time we're going to continue searching for the 29, but now only considering these elements. And that's it. We have an else. Here you can think about, well, the else should have another condition, and the other condition should be middle lower than target. But just because we already compared the equal and we already compared the greater than, by default, there is no other option. If it's not equal and is not greater, then it's going to be smaller. So it's okay if I have here only the else, nothing else. And if you notice, if is the middle smaller, that was another option, well, we change the start, middle plus 1. So if instead of searching the 29, we're searching for the 100, and the 100 is here, and the middle is smaller, then we never touch the end. It will continue with 10. But now the first, instead of being 0, is going to be 5 plus 1, 6. We're going to search for the 100 in that part of the array. Did you notice? The element that I am searching for, and whether or not it's greater or smaller than the middle, is going to define in the next iteration if we review 0 to 4 or 6 to 10. And with that, we reach the bracket for the loop, and we go back. If we go back and this condition was executed, we found the element, the loop is going to break, and we return, as I described before. But if that was not the case, go inside of the loop, calculate the middle again. So you can be calculating the middle here too, if you're looking at the 29, or if you're here, which one is going to be the middle for this one? 10 plus 6, 16, divided by 2. Depending on what I am searching for, I am searching here between 0 and 4, and the middle now is 2, like in my example with the 29, or I am going to be searching here between 6 and 10, and now my middle is the element 8. And what is going to happen? I am going to compare again the if. The data in the middle is equal. If yes, I found it. If the data in the middle is not equal, then I need to compare if the data is greater or smaller. Therefore, I am going to decide if I am going to search between 0 and 1, or I am going to search between 3 and 4, or if I am going to search between 6 and 7, or between 9 and 10. I am giving you all the possibilities depending on what are you searching for, but you already know for the 29, we end here. For something else, like the 36, we could end in a different part. And basically we're going to do that again and again and again until we stop here, and that means the start at the end cross, which means the element that we're searching is not there, or we found what we are looking for. Searching is a method, a loop, a condition, and playing with variables. This is the kind of things that you're going to have in your exam. Variables, conditions, loops. But the interesting part is the result. In this case, tell me if one particular element is in the array or not. It's not so complicated. I mean, I am sure that you want to play with this, copy paste the method and run the method with different numbers and different times and see what happened. I am sure that you're going to do that. However, it's like 3 conditions, 4 variables. It's not exactly the easy one to read. Again, it's not hard, but maybe we need some time to understand what is happening. What about the recursive solution? Recursive solution, same problem, different approach. Binary search with recursion. Remember the problem. You have an array, you have the small element index and the last index, and you calculate the middle. That is the main activity here. First element, last element, and the middle. Okay. And considering that, what we are doing is, if the array in the middle is equal to whatever I am looking for, then I am done. I found the element and I need to return the index, right? That is what we did. If they are equal, done and return. The other two cases is the element I am looking for is smaller or the element that I am looking for is greater. If that is the case, what I want to do is to search again. Search again. Now, instead of searching from this one to this one, I want to search from the first one to n-1 here. Or if what I am looking for is greater than the one in the middle, I want to search from this one to the n. n plus 1 to the n. Right? That is what we're doing. Search again, but now with different index. Yeah. This is the method with recursion. What happened here? Name of the method, use as before. Parameter number 1, the array. Parameter number 2, what I am looking for. These two parameters are the same that before. Now, because I want to do this recursive, I am going to send as a parameter the index. The index, lower and higher. So now I have a method with 4 parameters instead of only these 2. If you remember in the previous one, these ones were not parameters, were local variables. But now, because I am going to do a recursive method, I do not put those as local variables. I put those as a parameters because as a parameters, they are going to be local variables, but the value for those variables are going to come from another method, from a previous copy. So remember this idea with the clones is the clone 1 is going to give to the clone 2 some values that this clone 2 needs. And this clone 2 is going to send to the clone 3 values that that one needs. And that is going to be the chain. Inside of the method, calculate the middle. Use as before. If condition greater than, if condition equal, if condition greater than for the middle. Very simple. If the index low is greater than the index high, remember, low, high. When this one is greater, mean that I crossed the point, that I didn't found the element. So return -1. Oh, they are equal. Return the position. Oh, you know what? The element in the position M is greater than the one in X. is greater than the one that you are searching for. Call the method again, and now send as a parameter the same array, the same element that you are searching for, but the new low is going to be the same one that you received, but the new high is going to be m minus 1. Oh, you know what? No. Not equal, no greater. By default, the option is smaller. Recursive call, same array, same element, but now the lower is going to be m plus 1, and the higher, the same that you received. This is this. Return minus 1, return the position, or make recursive calls changing the index. Not really. For the final, you need to understand recursion. You're going to be given a program like this, and usually the question is going to be, tell me what is the output. In your data structure class, guys, you're going to use a lot of recursion and a lot of arrays and a lot of loops and conditions. So remember, this class is giving you tools that you're going to be using a lot in your next classes. Well, I am talking about if you're related somehow with informatics, computer science, software engineering. If you're taking a data structure class, all this is going to be there again. But so far, at this point, what I need to evaluate in your final exam is that you understand something like this, that you can tell me what is the output of something like this. The skills that you're going to develop in the next courses is, okay, now use the tool and from scratch, create a recursive method for a particular problem. That is coming. So, recursive solution, binary searching, and also the while loop solution for binary searching. As usual, copy paste these codes, play with them, and be sure that you understand what is happening here. You want to know what happens if I have an array that is not in order and I try to apply this? Try. It's not going to work, but I want you to play with this. Do not be afraid to copy the code and play with different values. This one, for instance, can you do very simple? I just show you the methods, but can you do a program that, number one, ask the user for how many elements the user wants in an array? Number two, I can give you 10. The computer creates the array of 10. Next step, can you make the program to ask the user for that number of values? Like, I want an array of 10. And then the computer asks me for 10 numbers. Your grades. So how many elements do you want? 80, because I have 80 students. Give me 80 numbers. One by one, I give 80 numbers. Your grades. And then, can you make the program to ask me, do you want to search a number? Yes, I want to search a number. Which number? I want to know if I have a student with the grade 99. Search for the 99. Tell me if the 99 is in the array. Tell me if I give you the value 99. If I give you the number 99, give me in which position of the array is the 99. And I invite you to do an array with a lot of elements and try with linear searching and binary searching. And maybe you will notice the difference in terms of speed. You can use, for the initialization, you can use the main method. I mean, The easy solution could be one class. In that one class, you can have the main method. In the main method, you can ask the user for the size of the array. You can ask the user for the values for the array. So all that could be in the main method. And then the main method is the one that could maybe call for the binary search method, either the recursive or the linear. And that could be all the program in just one class. Good. So this is searching, a little bit of recursion, a little bit of loops. Please copy and compile this, play with this. If you have the opportunity, do the exercise that I just mentioned. Any question, please let us know. And remember, this is very useful for you to practice for your exam. The exam is not going to be like implement the search method, but understanding this help you to practice a lot of different topics that we reviewed in the past and that are going to be on your exam. Good? So any last minute question? Great. See you tomorrow, guys. Thank you.